My name is Hannes Kühlmund. I'm part of the SUSE product management. One of the products I'm responsible for is live patching, and with me is Wojciech.
Hello. Wojciech Pawlik, Director of SUSE Labs, the department that actually developed live patching.
So I take like 30 minutes, 25 minutes for the first part of the presentation, then Wojciech jumps in with some of the technical stuff. Because if I present it, he will correct me all time, so I think it's better if he presents that. And then he gives it back to me for the vouchers here. So solving the paradox, SUSE Linux Enterprise live patching roadmap. Again, this presentation doesn't come with lots of code. There's basically not much code in here. There's more like, we go one level up, more like on a conceptual level, high level, to talk about live patching and actually why we think it's a good idea to do that. Here are a couple of examples that may sound familiar to you. The first one is a hosting provider's scheduling downtime for 9 p.m., which is a good time for downtime because usually the business hours are from morning till afternoon. But apparently the downtime of this hosting provider affected a streaming service, which has actually a lot of customers running the servers at 9 p.m. So not a good thing. And basically, if you schedule downtime, someone will be hit, someone. So you cannot really avoid that. Another example, there was a CVE of kernel vulnerability. It's a hosting service for developers that was affected, where developers can upload their code and let it host their web application. They make money with that. It's their business. I mean, those are small companies using services of another company for hosting. If this company has a downtime of 1, 2, 3 hours, not really good. Or, that's my favorite, about an online game. The online game developer said, okay, there's an update of the game happening, so while I do the game update, let's do some maintenance as well and update a couple of other packages. And then it's like, it first update, it didn't work that well, we need more time, update 2, the issue is probably a little bit severe, and then the fourth update, it's all harder than we wished. So there are coming things together which you don't have under control. So let's start with the downtime quiz. On the left side here, I have planned downtime and a couple of characteristics for planned downtime. So it has a regular cadence, be it monthly, quarterly, yearly. Usually happening on the weekend, of course, because you don't want to interrupt your business hours. It's in alignment with all the stakeholders. All the stakeholders are aligned. Everyone knows downtime is coming, all good. You usually do a combination of tasks because you may want to change broken hard disks, you want to do some stuff on the AC cooling unit, some maintenance, getting new servers in, changing cables, updating software. So usually, because you have the entire weekend. And there are some technologies from SUSE, like SUSE Manager, how you can with those you can optimize that. For example, the time needed for installing updates, as we see in the keynote, you just press a couple of buttons and then everything runs automatically. So question for you, unplanned downtime. What is the cadence of unplanned downtime?
No.
None? Yeah? Actually, yeah, there is no cadence of unplanned downtime. It just happens. So, and when does unplanned downtime happen? Is it on a weekend? No. It's on Christmas Day usually. Then when you need the systems up and running because the husbands need to buy the last time, the last Christmas presents they forgot apparently, and then there's downtime. That's really bad because even if the cash register isn't working or Amazon isn't working, it's not really good. What about alignment? Yeah, of course. It's basically no alignment stakeholders. Maybe one stakeholder's aligned, maybe two. But you're basically hit by like, oh my God, unplanned downtime. It's like you want to do the travel expenses, you pile all the travel expenses up there and say, okay, now I do travel expenses, you start going into the system, downtime. That's what happened to me last time. So, of course, you only fix one particular problem causing the unplanned downtime. If it's a kernel bug, you need to update the kernel. If it's a hardware failure because whatever, you don't have enough RAID disks configured or so, if a network cable is burned, whatever, only one thing is fixed because Again, it doesn't happen on the weekend. Nobody is aligned. You need to fix those as soon as possible. And there are a couple of technologies to optimize that. I mean, to avoid basically unplanned downtime. Can you name a few? Anyone who knows a couple of technologies? I just named also some. RAID, for example, RAID systems. Anything else comes to your mind? Cluster, yes. I've listed a couple here, like uninterrupted power supplies, RAID systems, load balancer if the application supports it. The RAS features in the hardware itself, like reliability, availability, serviceability. That are the features where the components on the main board, like the CPU and the memory, instead of just breaking and doing faulty calculations, let the operating system know, I'm broken, please take me off the scheduling. Like what Unix had, the Unix servers had in the past, also available now with Intel servers. System rollback is one thing. We have a /12 with ButterFS. Something is messed up, you can actually roll back to the last known state, continue working, do the root cause analysis later on. HA and Geo. Virtualization, for example using VMware. Is it fault tolerance? I think it's fault tolerance. You have copies of 2 VMs running, one shadow, and then one system fails and operations continue in another VM. And a question mark. And of course, you might have guessed that's live patching. But before we put live patching into that box, does any of those technologies help you with avoiding downtime when there's a security fix that needs to be applied? Not really. I mean, with a load balancer, you can start patching one system, taking off the load balancers, and do that sequentially through the system. But basically, none of those technologies help with security fixes. But on the other hand, you don't want to have downtime, because your important systems should run. So, again, the quiz. So who will win? The security guys telling you need to fix the system, or you who says, no, I don't want to stop the system because I want to make my users happy? Obviously, the security folks usually win. Sometimes, maybe the operation folks win, but it's common sense because there are laws and regulations, for example, the PCI DSS. When you process in your system credit card information, you have to patch a certain vulnerability when it is known within 2 weeks. If you didn't patch it until...
In this scenario, both databases are loaded in memory, so if the master database goes down or have a problem, the takeover take place faster because the database is already loaded on the secondary server. But you have a problem here. The second server is stopped, is not make any process. So some customers asked if this, the secondary server could not be used for example, KIA or testing database. So you achieve now the second possible scenario that is called a custom optimized scenario, where we have a production database running the master server, and we have the secondary server running a system replication from the production database, but without preload memory. And we have a KIA database loaded in memory. What we have here is, if the master server goes down, you have to stop the KIA or a dev database on secondary before starting the production on the secondary server. So the takeover process, you take more time to get the system back again. Both scenarios here could be implemented using both single and also MDC, multi-tenant database. And some customers also requested us that they need some kind of procedures for recovering problems on the site, because when we're talking here about the failover automation, both servers are in the same site. So we have another option, that is this one, where we have the master server running the production database. We have the secondary server running the production server as preloaded memory off, set as off, and we have the QA dev database running loaded in memory. Also, we have a remote site named here as site B, where the production database is also replicated to this remote site. In case the customer has a problem with the site A, the business could be returned back in production using the database running in site B. This scenario was the scenario that was implemented in the customer. Okay, this represents the both the ACC and also the APO SAP applications using SAP HANA that was implemented. You have questions?
So your production is running on MDC and your non-prod is running on MDC only or MCOS? MDC only.
Yes. All the database here are running in MDC, both for production and also for development.
This is transparent. When you activate the synchronization between the nodes, it will sync all databases, because all databases are confined in the same instance. So the synchronization come across the instance and not for a particular database inside. Sure. The process is automated for the site the site A, and the process is manual at the site B. Yeah, so you have to take over on the site B manually, and maybe it's the better place if you have a VPN across those sites. You have to manually take the virtual IP up on the third node.
It's important to note that the disaster recovery operation is more a management decision than a technical decision. So if you need to switch for disaster recovery or need to operate from a disaster recovery, you need to get approval for management before doing that. So it's the cause that make us to do this the site B operation manually.
Today we have kind of half terabyte. Yeah. SUSE HA, the high availability product that comes in slash for SAP. Yeah, that's a plugin called HANA SR, which is developed by I don't remember the name, but it's a SUSE engineer. It's open source. It's on GitHub, but when you get the slash for SAP, it comes automatically with the SAP repositories.
For
Yeah, sure. And the KA comes down and so on. That's actually we put it in the references of the presentation. We have a white paper from SUSE about this process. So we will not go deeper in the technical details about the implementation because it's well documented. We are more focused and to show the business details with Walter, and a little bit about the technical problems that we have to solve. But we want to show an overview of the all case study.
In the end of the session, if you need more technical details, you are free to ask us or send us an email. Okay.
So if you want more deeper information, so on the showcase, we have a booth in the SUSE area where we show also all the SAP scenarios and also the developer the solution.
Okay, okay. In this project, we have found a bug with this multi-tenant. You explain a little, because I think that is not available on the production version until now. Okay. Um, um, there are two components in the high availability extension that we use for this custom optimized scenario. The one is the SAP HANA SR, and the other is the SAP database. So these two resources were used to provide this custom optimized scenario. When we are talking about system replication, it's important to note the modes available for replication of data between servers. We have 4 modes of operation for system replication. The first is the mode sync, and we have an option for full sync. This is the more resilient options because you have no data loss, but you have a problem here. If the master, if the slave server goes down or stop responding, also the master server stop accepting requests. So you have to think about this option because could not fit your environment. So take attention to these options. The second option is the mode sync. In the mode sync, you have the information being replicated from master to slave, but if the slave server is not responding, the master slave, you continue accepting requests and it would not stop. But you have some circumstance where we could have some kind of loss of information between the system replication.
No, that's because the primary server will continue to go on and accepting those transactions. And if you have a takeover on a blind secondary server that which is not receiving the new operations, you obviously will have data loss.
The third mode is the sync main. When sync main is happening, you have the master replication the information for the secondary server, but the information on the secondary is confirmed as saved only after being writing to memory. The secondary do not wait for the information being written to local disk. So if you have a problem in the middle of the operation, the secondary could lose some information too, because the information is only saved in memory first. You have no guarantee that information was saved in the local disks.
That's because the primary, when receive some operation, some transaction, it ships out to the secondary node, and then it will wait for the confirmation that the operation is taking in place on the secondary server. In the mode sync, this operation have to go to memory and disk on the secondary node. In the mode sync man, this operation has to come only only in memory on the secondary node. So if you have a crash before the operation is written to disk on the secondary node, you will have data loss about this operation.
And the last mode is the async mode, where the replication happens from time to time. And in this mode, you have more options to implement the asynchronous replication. One of these modes is the delta data shipping, where the master keeps information for some time before replication that information. There is a timeout parameter that you could set from how many seconds should happen that synchronization. And you have a new mode that was implemented in SPS 10, that is log replay mode, where the information is replayed transaction by transaction.
There are important things to consider which mode you will choose. In the Delta shipping, you need to have less broader connection, because we are shipping data in 10 minutes, so the compression level is higher. In the log replay mode, we are shipping transaction one by one. So this is more cost in the connection, the data, okay. more costly data.
On our scenario, you have used synchronous replication for master to slave into the same site, but for the remote site, you are using asynchronous replication. Okay. When we start or set the system for replication, you have to know the status that are the states that system replication could be. You listed here those states, now initializing, syncing, active error. So it's important to know, or better, it's important to monitor when we have a system replication, in which state your replication is, because if something is going bad, you have to take some actions to return the synchronization to active. We put here a query that could be used to detect that. So you have some monitoring system in your environment. It is important to include this execution, this SQL on your monitoring system. And we have here the flow from those states, from now to initializing, and depending on the kind of operation that was done, the change of the states available into SAP HANA system replication. When you set system replication, it's important to note that you need to have the same settings defined on both servers. It's not it's important to do that because your system could have unexpected results when you run your instance with different parameters. So it's possible to check that using Running Studio, but in SAP 12, it was introduced a new option inside the configuration that allows you to automatically replicate the configuration between servers. So if you make some change in the master server, this configuration is also changed in the slave server. Our project was based on SPS 10, but we found this information for SPS 12, and we know it's important that you know that this kind of information is important for our environment too. Some considerations about the environment. You have included here some of the options that we use it for production, for QA and development database. When you are talking about storage, we use in the project EPMI, but you also have the SBD option available, so you can choose the option that better fits our environment. When we are referring to the SAP HANA in the appliance model, you are not using storage, so don't make sense to use storage only for SBD, so it's better using EPMI. But you are working with the TDI model, makes more sense using the storage for SBD. We used 3 resources from high availability extension: this SAP HANA topology, the SAP HANA, and also the SAP database resource. We make a note here about setting this tonnage. It's important during your installation and during the test set this tonnage mode to disable. So setting this tonnage enable to false is better, because during this test you could have some problems with timeout in your servers. You start rebooting constantly. Another option that we used in the project was setting this tonnage action to power off, because we don't know what happens to the environment that makes the environment tonnage a server. So the better is powered off the server and make someone make some manual operations to restore the environment. So we prefer to use this tonnage action as power off, and also setting the open IES servers as not bootable.
Yeah, that's because any HANA operation can take 10 or 15 minutes to preload the data from disk to memory. And if we leave the server decide alone to put up and start HANA, maybe we have a transition from the primary to a secondary node or something like that, and it can cost 15 minutes of installing or downtime in HANA server, because we are in cost optimized scenario, so the operation can cost time.
Two other options that is important to take attention is the preferred site takeover and also the automated register. When you set preferred site takeover, if you set that option to false, when something is going wrong in the cluster, the first approach is try to restart the server on the same server before trying to take over to another server. So you need to study what is better approach fits your environment. The other option is the automated register. When you set this option to false, in case the server goes up after a failure, the server will not register automatically to the SAP system replication. So you need some manual intervention to detect what happens and manually restore the system replication. But if you set this option to true, when system goes up again, after passed the duplicate primary timeout value, the former primary will be registered as secondary after the synchronization, because of the balance procedures in high availability. You have a migration taking place from slave to master to allow the cluster to put again the development database and slave up again. Sorry?
Yeah. That's the when your primary server comes up again, and then the better for safe, it's to register the reverse directions of the system replication. But you have to care about this, because if this reverse comes up, and when the primary server becomes okay in a active state again, your configurations maybe can set the cluster to run more services as possible. So your KA database is down, so the clusters comes out with, hey, I have a services down. Maybe if I comes master to primary again, I can run up with the KA. So maybe you will have a downtime again. So it's better to do all the process manually.
The high availability configuration is done in some steps. First of all, you need to install SAP HANA. Is the first step of the configuration. After that, you start the configuration of SUSE high availability extension on the first node. Defines configurations about bound channel for cluster communication, disable open IES during the boot. This is our recommendation. Configure also the name and resolution SAP HANA so that you could set the interface, the network interface that will be used by SAP HANA for system replication. The idea here is that you have a channel for cluster communication and a channel specific for system replication. The idea is separated this kind of communication to avoid some kind of collisions or problems.
The better situation is to have a host name specifically for replication. So when you register the server or the replication, you use this name. When you are reaching the server with in QA server or application server, it's better to use another channel. So you can use another host name for this. It's better to for isolation in kind of performance to use a dedicated channel for replication.
After doing these configurations, you start the SAP SUSE high availability setup doing ensuing the command /ha init. We have some recommendations here before starting the process of joining the second node. So if you need modify the kind of communication used for your cluster, because the default configuration sets the communication for multicast, but you have some specific network device in the middle that blocks some kind of configuration, should be interesting to set the kind of configuration for unicast or configure also the network device accordingly. You need also decide if you want to set encryption for this communication. The default command for setup does not enable encryption. And also define the files that should be synced between nodes. So after doing that, on the first node, you go on the second node and issue the command /ha join. After doing the initial configuration of high availability, you have to check if the SAP host agent is installed. We listed here the command that we could use it to check that. So it's an important part because the resource agent in the high availability extension use the SAP agent to issue commands to the SAP HANA. So it's important to check if host agent is installed. After that, you need to create an initial full backup of the database. Without a full backup, it's not possible to do a system replication. We could set the system replication, but the system replication will never start without a full backup of the database. Depends on the kind of setup that you did. You need to do more than one full backup, because when we are working with a multi-tenant database, you need guarantee that all databases were backed up. After that, you need to create a user in your SAP HANA database and also set a user key on both servers so that we could issue SQL commands through the SAP HANA database without issue a password. So you create a local user key mapping a local user to SAP HANA user.
Um, I don't remember if the last step is on the white paper.
No, it's not.
That's because the resource agent is going to monitor HANA with database operations, with some consultations in the database, and that the last step sets a higher priority for this user. This user will be used to monitor the database. So we are setting a higher priority, and this is useful in high load scenarios. So when the database comes with a high load, with a lot of operations, we guarantee that that user will can monitor without any problems.
And avoid some problem with timeouts in your
Yeah.
high availability. So it's important. This is one option that we didn't saw on SUSE or other documentation. We found that only in our SAP documentations.
So with newer HANA versions and the newer versions of the resource agent, that's not needed anymore.
Okay.
Okay.
User store is not needed anymore because SAP has provided an API in the
Okay.
Yeah.
I didn't know about that. Good information.
So is there newer version of SUSE or
This newer version of HANA, or we can only query the database state with an SQL command, and later on SAP implemented an API for that, so we can talk to the API directly and don't need to
Okay.
query the database.
Good to know. We'll check that on last version. So it's important to check that the query is working without password. Also, if you have or you are planning to upgrade your system, it's better to start with this slave server. So one of the restrictions with the slave is that the SAP HANA software version of the secondary has to be equal or nearer than the version of the primary. So it is important also for when you are trying to do zero downtime procedures or want to plan on upgrade of your system, always start in the secondary server. We also have here the commonly used for checking the replication. We have two options to check that. And we also have to set the SR takeover script to allows during the takeover that some of the parameters are adjusted to fit memory, to fit the required memories of the takeover process.
So it's kind of you have to manually set constraint in the database to avoid the secondary node to preload the tables. So you can, with this, you can run the KA and another instance without problems, without have memory limitations. So you are restricting the production system in secondary. And you have to set this hook inside HANA. It's a configuration file, which it's responsible to take some operations before a takeover. So before a takeover, the HANA will unset these two restrictions on the secondary node to perform a takeover and preload the tables in the secondary node.
We have also find some a bug on when you use a multi-tenant database. So when we had used the SAP database resource, OCF resource on high availability extension, there are some scenarios where we are using multi-tenant database, and when we list the process, we have many HDB index server process running, and what happens is that the SAP db. SH script that is running by the SAP database OCF research agent, got this kind of information with, in this case, using 3 databases, running. So the logic of the script didn't work perfectly because it was returning 3 lines of information. We have put a request to Cluster Labs to correct this step. So
this was not in the HANA SR resource agent. It's specifically on SAP DB resource agent. That's because in the resource configuration, you cannot say that, okay, I have to monitor several services with the same name. So before the MDC, we have one service, only one service, and now with multi-tenant database, we have many services running with the same name. So the code was prepared to monitor only one, and we have to adapt this to monitor multiple services with the same name. So it's in the CAS and the development database resource agents, not in the production resource.
During our project, we have been using some tools for stressing the database. The idea is to put some loads on the database to detect problems with timeouts that were defined during the configuration. So you have used an open source tool called HANA Stress. This tool is available for free at GitHub. I will check. I think I forgot to put the address here, but it's easy to find in the internet.
It's up there. GitHub.
Okay. Oh, okay, it's here. So you have included here some example of execution of this script. The idea was to create 200 tables with more than 1 million rows using 20 threads. So this is a way to stress our database, so you could adjust your script to fit your demands. It's important after doing your tests also to reclaim the area that was created by this script, because you have more residual data available there. So you have to run some reclaim command to reduce the area used by the script. For troubleshooting, you have been using information from var log messages and also the script HB report, where we could set an interval of data to get information about an incident. So it's a way to detect problems or get information about a problem that we have with the environment. And it's important also to know that SAP HANA also create crash dump files when some service goes wrong. So analyzing these files is a good point to detect problem with your SAP installation.
So when you are testing on and to maintain the server, maybe in some time we have to stop or make some operations in the safer way. So if you want to make a maintenance or some operation that needs to down the HANA database, the better way is to stop the all cluster resources. So you can get in the primary database and simply stop the cluster service. And I think
also, there's an option in the cluster to put the cluster or the node in maintenance mode. So you have found some other customers in Brazil that are not don't know so much about the high availability instances and forget to set the maintenance mode of the node of the cluster to true and start to make some changes on the SAP HANA database, installing new instances, remove, and things go wrong on this case. So it's better to take attention to the maintenance procedures from your cluster and your SAP database to avoid problems happen on your instances.
So in this case, you with the first command, the cluster will goes down in the primary, and without maintenance mode, if you want to perform a takeover to the secondary, you can stop the cluster. And I think that the safer way to comes back, it's to clean up all the replication on the primary and register the primary node as a secondary and start run HANA manually. Wait until it finish the sync, stop the HANA, and then start the cluster resources again. So when you start the cluster resources again, if you configure it to be to more resources stay up, the clusters will go up and figure out that the CAS database is down, so it will perform a takeover back to the primary server. So if you want to take some operation on the second node, you can simply stop or start the cluster resources. Should be fine because the primary continues on the primary server. So on the disaster recovery node, you can start the replication enabling the secondary node as a sync source. So the DR node will sync, will use as a sync source the secondary node. So you can use that command to start the replication to the disaster recovery node, and that is the command to unregister this replication. When you have to shut down your DR server, it's better to deactivate the replication. That's because some monitor commands that cluster are trying to perform will consider that the disaster recovery node. So HANA can take more time to answer because it is unable to find the replication state on the disaster recovery. HANA has some kind of timeout, and the cluster also have some kind of timeout, so that can be a problem. So it's better to unregister the disaster recovery first and then goes down. I'm sorry?
When you did async replication to the DR side,
Yeah.
how much time did it take?
That depends on the size of your band.
Stress testing when you carried out.
I don't remember, but we had 50 megabytes connection between the sites, and for half terabyte, I think we have 2 days of syncing on the first sync, and then when the disaster recovery goes down, it will calculate the delta. So it's only on the first time. So a 50 megabyte with delta shipping is performing well for a half terabyte database. for backups, I think no. I think no. It's better to check on the HANA documentation, but I think you cannot perform operations on the secondary node. Yeah. Only for ship replication, but I think you cannot take operations on the secondary node. But in this scenario, they are using what's the name of the
Backup tool?
Backup tool, Backint. Yeah.
Yes. What's the name of the tool that you are using? Remember Visan or? Okay.
So
I think that's Visan. I think that is Visan. No. No. Okay. So I don't remember.
So we bring some references about this scenario, and obviously the notes that we care about to implement, and references. As I said, the SUSE has a good white paper about the process. It's step-by-step process. So
and the SUSE documentation was updated now in August, if I remember correctly, with more steps than before. So when we did this project in February, the documentation was not so updated. So in August, if you check now, the last version of the documentation is better than before.
so much better.
Much better.
It includes the hook steps and so on. So it's oriented to MDC also.
We refreshed all the documentation and are also looking for SUSE11 and SUSE12.
Yes.
Because the HA step is a little bit different with a few commands. So we did both and refreshed all the documentation and showing more scenarios.
Yes. We saw now that there is an option for inquiry replication available that was not there before. So
if you choose to use HANA on H8 scenario, you also can run your WinQuery replication and all the other part also in high availability scenario. So you get covered in uptime also.
thank you for your time, and you are available here if you need more questions, or our mail is available here. If you need chat us later or now about more technical aspects of about our environment, Walter is here also to guide you, or is free for also receive questions about the environment that they have there. So thank you.